Hello everyone, I'm Pooja from Group 2. Here for this project we have taken two dataset values, and the first dataset sourced from the US government's data catalog focuses on border crossing entry data. It contains information such as port name, state, port code, border type, date, vehicle category, and traffic count. The goal is to develop a predictive model using PyTorch to forecast border crossing traffic by leveraging variables like port location, date, and specific measures. The model aims to enhance resource allocation and management, capturing seasonal traffic patterns for effective border control. The second dataset available on the data.government revolves around popular baby names featuring variables like year of birth, gender, ethnicity, child's first name, count, and rank. The objective is twofold. Firstly, to build a PyTorch generative model that identifies trends in naming based on gender and ethnicity. Secondly, employing TensorFlow. The aim is to create a prediction model that estimates a name's future popularity, shedding light on how naming trends evolve over time and across diverse demographic groups. And here is the code for baby names dataset exploration. And this code explains the data baby names dataset and uses Seaborn to create a count plot of baby names based on gender and ethnicity. The Levenstein distance is calculated between two names like John and John using the NLTK library to measure their similarity. And these are the top five baby name trends. And the following code extracts the top five baby names based on rank and plots the trend for these names over the years using matplot library, and utilizes the group by function to aggregate counts of each name by year and then plots the trends. And coming to the word cloud of baby names, and this code generates a word cloud visualization based on the baby names, creating a visual representation of most common in words in the data set. And coming to the label encoding and normalization. This is the code for the label encoding and normalization, and it clearly explains the variables like gender, ethnicity, child's first name or label encoded to convert them into numerical format. And coming to the numerical features, it mainly focuses on the year of birth, count or normalized using minimum and maximum scaling to bring them to a normal scale. And coming to the TensorFlow model training, and this is the code we have used in the TensorFlow model training. It mainly targets and features are defined, and the data set is split into the training and testing sets. A simple network model is created by TensorFlow's Keras API, and the model is trained and evaluated on the dataset. And here is the code for the converting date column into date time, and this converts date column to a date time format using the pd.do datetime function, specifying the format as D and B date month abbreviation, and it then clicks for missing values and dropped rows containing NaN values. The code displays information about the data frame including non null counts and data types. And coming to the data exploration and visualization, and here is the code explained in the data exploration and visualization, and mainly it explains about unique values of each attribute column in the data frame. It identifies unique indexes for the point columns, then groups by port code, and create a pie chart showing the distribution of counts of unique point values for each port code. And coming to the bar plot with plotty express, and this is the code using for the bar plot for the plotty express. And here we are using the temp value, and mainly focuses on the measure and the value, and this code mainly explains on the plotty express to create a bar plot showing the sum of value for each measure sorted in the descending order. And coming to the next set, it's data pre-processing and model training with TensorFlow, and this is the code we have used in the data pre-processing and model training and TensorFlow. And it separates the target variable value and input features X. It uses column transformer for pre-processing, applying standard scaling to numerical features and one hot encoding to the categorical features, and the data set is split into training and the test sets, and a simple neural network model is defined and trained using TensorFlow. And coming to this, the parse matrix handling and the model training with TensorFlow. Here we are using some code which includes Adam and mean squared error and everything. And here the main aim for this code is a sparse matrix and the xtrain to the sparse tensor and the xtrain parse tensor for TensorFlow capability. It compiles it compiles and fits the TensorFlow model using the parse tensor. The model is then evaluated using the test set in the parse tensor format. And coming to the next code, it's model training by PyTorch, and this is the code explained in the model training and the pie chart. And here we are using like so many variables like port code, latitude, longitude, num, cat, port name, state, border, measurements, and value. And the main aim for this code explanation is the missing values in the latitude and the longitude columns, and drops the point column and performs pre-processing using column transformer. The PyTorch model is defined and data is converted to PyTorch tensors. A PyTorch dataset and data loader are created and the model is trained using a simple training loop. And and here we got the output for the coding and everything, and we have run all the test cases. And in the summary pre-processing and well as cleaning, we used the TensorFlow and PyTorch to generate models for two different data sets, one with the popular baby names and associated features like year of birth, gender, ethnicity, count, and rank, and another with the dataset, border crossing entries, and variables like port name, state, port code, border, date, measure, and value. Using characteristics like year and ethnicity, a predictive model could have been created for the baby names dataset to predict the popularity rank of the names. And this might have helped with the sociological research and perhaps shown cultural trends. The dataset on the border crossings may have been utilized for forecast activities and everything. And this is the output we got from this code. And thank you so much for this.